Alright, hey guys, Devin Sherry here. We're back in Unreal Engine 4, continuing our static circle and dynamic circle blueprint. Last time what we did is we created the materials and the blueprint base for these two blueprints. So again, we made the materials here. So a pretty simple material for both. They're relatively the same. And then we went ahead and created both the static circle blueprint as well as the dynamic circle blueprint. But just only the components. So we have the two circle meshes and the roots for them, but we haven't done any kind of scripting or any development of logic. So that's what we're going to do today, but we're going to only start with the static circle for now, and probably next time will be the dynamic circle. So to get started, we're going to go into the construction script of our bp_static_circle script here for blueprints. And what we're going to do first is create a reference so that we can have a material instance for that static circles material, because we will need to alter its color as well as the intensity of the scalar parameter that we created in that material. So let's go ahead and drag out from the construction script. If we just type in create dynamic, and we'll get a create dynamic material instance. But we need to do it for the actual mesh, so let's do that. Create dynamic, and the one right here for static circle mesh. And then from the return value, we'll pull from that and just promote that to a variable that we'll call static circle mi for material instance. Let's compile that and make sure there's no errors. The next thing we're going to go ahead and do is create a new variable. But the way we're going to do it is actually grab the static circle mesh, and pulling from that, we're going to get the relative 3D scale. So relative scale 3D. And then pulling from that, we're going to promote that to a variable, and we're going to call this one default static circle scale, because we will be altering the scale of the static circle, and the dynamic circle will scale appropriately to that as well. So let's get that connected. So right now we're just setting the default size of the static circle mesh to that vector variable. And last but not least, what we need to do is get a reference for our dynamic circle blueprint. So to do that, we're going to pull out here, do get all actors of class, and then in the drop down here for actor class, we'll just go find bp_dynamic circle. So it's going to be right there. And then we're going to pull from the out actors array pin. We're just going to do a get, leave the value at 0, and then pulling from this get, we're going to cast 2, and it's going to be bp_dynamic_circle. From there, plug those up, and then last but not least, we got to create a variable for it. So we'll pull the pin from as bp dynamic circle, promote to variable, and we'll name this variable dynamic circle reference. And then we can compile, and that's going to be the construction script. That's everything we need. So again, we just created a static circle material instance variable so that we can reference the vector parameter and the scalar parameter in that material. We have a reference to the scale so that when we need to increase the size dynamically, we can do that. And then we also get a dynamic circle reference to that blueprint in case we need these two to talk to each other, which they will need to. But that's done, so let's go to the event graph and actually start doing the main logic for this. So we're going to need two events here. One's going to be event begin play, and the other one's going to be a custom event that we're going to call later on when we start working on the dynamic circle blueprint, but we're going to create it and put it into place right now. So let's add a custom event, and we'll call this update static circle. And what these events are going to call is basically the change of the circle location, the change of the color of the circles, and change the scale of the circles. So we do the event begin play because we want that to start right away. And then for the update static circle, that's going to be called every time we click on the circles when they're moving and we're trying to match the shape. So that when you click it, it'll delay a second or so, and then it's going to call everything again so that it changes on the fly. So that's why these two events exist. So the first thing we're going to create in terms of the logic here is we're going to start out with a macro to change the circle's location on screen. So let's go ahead and add a macro, and we'll call this change circle's location. And then over here for inputs and outputs, we just need one executable pin for input, and we'll name that in. And then one executable pin for output, and we'll call that out. We'll move the outputs section out of the way for right now. And what we need to do first is essentially make a new variable. So let's hit new variable. It's going to be a vector for our location here. And we're going to name this new circle location. We can compile, and we're going to leave its value at default at 0, 0, 0 because we're going to change that on the fly here. Excuse me. So what we're going to do is we're going to grab a make vector. And for the purposes of how I'm looking at my scene here, the location on screen, so up and down, left and right, that's basically going to be the Y and Z components of the location. The X is not a factor. So what we're going to do is each time we call this, we're going to generate a random float within range for both the Y and Z. So let's go ahead and right click, type in random float in range. And these are the numbers that work for me. You may need to alter these numbers to fit how yours is located on screen, but for right now we'll follow along here and hard code these numbers. So the minimum here is going to be 150, and the max is going to be 440. And this one's going to go into the Y. And then we'll copy and paste this random float in range, and then change its value for the minimum to 290, and then its maximum to 610. And then plug that up into the Z. And then what we need to do is we can hold down the Alt key and left click drag the new circle location vector variable in to do a set. And then from the output vector pin for return value of this vector, we can just plug that up. So right now, every time we call this, it'll get a random float in range for Y and Z and set the location to that position. But what we need to do now is tell the blueprint, hey, we want to set the world location of the static circle mesh to that location. So what we need to do is type in set world location for static circle mesh, plug that up, and then we can control left click drag the new circle location variable to get a get variable of it, and then plug that up. And then we need to do the same thing for the dynamic circle, because right now we're just telling the static circle where to go. So what we need to do is grab our dynamic circle reference here, pull from this, and type in dynamic circle mesh. And we basically need to get dynamic circle mesh. And then pulling from this, we can do set world location. So let's put that into place. And let's make a copy of the new circle location vector variable and plug that into the new location here as well. And then that's it for this one. So let's plug in the output here. Compile that. We can also do Control S to save. Let's go back into our event graph. And with that macro created, let's just left click drag out change circle's location and plug up both events to its input. So now if we play, it should change the circle's location. So right now it's kind of dead center. Let's see if this works. So I hit Control P, and there's the circle location right there. It looks like it's a little too far to the left, but for right now we'll leave it alone. But if we play again, location's changed. Play again, it's changed again. So what we may need to do, because it seems like it's far off on the left, let's go ahead and just grab our static circle, which is the bigger one. Right now we're seeing its location is at 550 in the X, which we don't have to worry about, but in the Y it's at negative 750. So what we can do here is kind of just move it around and see how far left it should go. So negative 40 seems good. So let's go back into the BP static circle, change circle location, and then for the Y, let's do negative 440 in the minimum range, and then let's drag it to the right. Looks like negative 1140 here. So the smaller number has to be a minimum here, so we'll do negative 1140 for minimum, and then max will be negative 440. So now if we Control P again, we should get a better range here. So each time we play, it's spawning at a different location, which is nice. And we can also do for the Z as well. So where it's at right now seems a little too close to the buttons there. So let's move both dynamic and static circles up, and then just grabbing the static circle again. We see it's set to 470 for me right now. So let's just move it up a little bit, see how high we can get it. So 670 looks good. So that could be the max. And then for the min, 320 looks good. So if we compile that again, we should get a better range each time we play. So that's working the way we need to. So what we need to do now is generate a random color for the static circle. So again, we're going to need another macro. Let's call this generate random color. And for the input pins, we're going to need 2 of them. One's going to be an executable pin that we'll call in. But the next one's going to be an integer pin that we're going to call random int. And then for output, we just need 1 executable pin that we'll name out. Well, let's get the output section out of the way for right now. Let's compile this and then go back into our event graph and drag it into our main blueprint and plug it up. And what we're going to do here, since we have this random int pin here, what we're going to end up doing is try to grab a random integer between 0 and 2, and depending on what number it is, we're going to generate a primary color. So if it's 0, we're going to generate a color that's primarily red, and then if it's 1, we're going to generate a color that's primarily green, and then for 2, we're going to basically generate a color that's primarily blue. So let's right-click and do random integer and range. Minimum value is going to stay at 0, max value is going to be 2, and then we're going to plug that up. Let's compile and then go back to generate random color. And what we need to do now is set up a series of comparisons and branches to see which number that integer is providing us here. So drag out from the random int pin, hit equal, we'll do equal integer, and we'll copy and paste this 2 more times for a total of 3, and then we'll connect these up appropriately. So the first comparison is going to compare that random int to 0, the second one's going to compare that random int to 1, and then the last one's going to compare that random int to 2. And then pulling from each of these, we're going to do a branch. So the first branch is going to connect to the input, and then the false value of the first branch is going to connect to the input pin of the second branch, and the same goes for the third. Let's compile. So if the first branch ends up being true, so if that random integer is equal to 0, that's when we're going to make a red color. So let's focus on that. What we need to do first is grab that static circle mi variable, so we have a reference to our material instance for that static circle. And then let's drag out and do set vector parameter value. And the parameter name will go back to our materials for the static circle, find our vector parameter, and we named it static circle color. So back in the blueprint, under parameter name, you gotta do static circle color. And then for the color value, what we can do is pull from this, type in make color, and then we basically need to give it values for this. So we can just make the red color section the number 1, but for the green and blue, we want to have a range between 0.1 to 0.5, any numbers like that. So let's grab a random float and range. Let's make the minimum 0.1, make the maximum 0.5, and let's make a copy and paste of that. The first random float and range is going to go to the green, and the second one's going to go to blue. So right now we have a color that will be primarily red because it has a set for number 1, and then green and blue are set to minimum values between 0.1 and 0.5. So no matter what, it's going to be a red color, but depending on the other values, it may be a different kind or a different shade of red. So now that we have that in place, let's go ahead and plug the true up into that set vector parameter value. And now what we can do is basically just copy and paste this. Hook it up to the second true, but for the second true we want to make it primarily green color. So for this section, we'll plug in the first random floating range to red. The green value will hard code the number 1, and then the blue value is going to be the second random floating range. And then last but not least, we're going to copy and paste this one more time. Oops. Plug in the last true here. And this one's going to be a primarily blue color. So we'll set green to the second random float value, and then blue will hard code the number 1. And now we have all 3 colors set. So let's grab our output and just connect these to that output. And the last thing we really need to do is for this last false, we'll just plug that into our output. So let's compile. And now, every time we spawn, the static circle should change colors. So let's see if that works. There we go. So there's a red color. So there's another red color. So something doesn't seem right. So let's double check our logic here and generate random color. So we got 0, 1, and 2. And what else we could do just for troubleshooting purposes? We can do a print string, and the return value of this can go into the print string, and then we can print to see what number we're getting, just to see if the color matches up appropriately. So we got 1, so it's a green color. We got 1 again, but it's a red color. There's 2, we're getting an orange color. 0, we're getting a red color. So we are getting random colors now. So we can disconnect this. It's not necessary to keep that there. So let's compile. Let's make sure it still keeps working each time. So we're getting that, getting that. So far it's working. But what I'd rather do here, instead of the false going into the output, we can just disconnect that. That shouldn't be necessary to go to the output. I'm just not liking how we're getting white colors. So let's try this. Let's put the false, let's plug it back into the top branch, just so it loops through them again. There we go. So that's done. So last but not least, what we need to do is set a random scale for the static circle. So again, this is going to require one more macro. We'll call this set random circle scale. And then for the input pins, we're just going to need one input pin for executable. Call that in. Same thing for out, but we'll call that the word out for the output. We'll move the output aside. And we need to create 2 variables here. Both of them are going to be floats. First one we're just going to call smallest static circle. Second one we're going to call largest static circle. Compile. The value of the smallest static circle we're going to hard code in the number 1. And then for the largest static circle we're going to hard code the number 2. So now what we need to do is grab that default static circle scale. We're going to need to multiply that by a float. And for this one, we're going to multiply it by the smallest static circle. And then we're going to copy and paste that. Instead of the smallest static circle here, we're going to do the largest static circle. So we have the multiplication for the smallest static circle size and the largest static circle size. So from here, we're going to break the vector for both. And since we're uniformly scaling the size of the static circle mesh, X, Y, and Z are going to be the same exact values, so we don't have to pick a particular one here. So what we can do is just right-click, grab a random float and range, and the min value is going to be the X break vector value for the smallest static circle multiplication, and then the max is going to be the X value of the default static circle scale multiplication with the largest static circle value. And then grabbing from this, we can make a vector and just set all the values to the return value that we have here. And then last but not least, we just need to right-click, set world scale for static circle mesh, plug that into the input, plug the return value of that make vector that we had just worked on, plug it into the new scale, and then plug that into the output. Compile, go back into the event graph, let's grab set random circle scale, plug that up. So now the scale of this circle should change each time we play. So we're seeing it change each time. So that's working. So the very last thing we're going to do for this tutorial video is just set a random static circle intensity scalar parameter so that it gets brighter depending on where we're looking at. So let's grab the static circle mi variable. Let's type in set scalar parameter value. The parameter name, if we go back into the mat static circle, it's static circle intensity. So let's just type that in. And then for the value, we're going to grab another random float and range. This minimum value is going to be 4, and this max value is going to be 8. And then we could just plug that up. So now if we play this time, the intensity of the glow should vary each time. So we got that working as well. So this is going to be it for this video tutorial. The next video is going to cover the logic for the dynamic circle. So that's going to be it for this one again, guys. Thanks for watching. I'll see you next time.